Hello students, let me explain the derivation of the electrical conductivity based on free electron theory. Here you can see that I am taking a cylindrical, I am taking a metal wire. If I zoom it, it looks like a cylinder. Okay, now let us take the cross section of the wire is A. Okay, I have taken a wire and the cross section of the wire is A. So this cross section is A. And this is my direction of the electric field. Now when I applied a direction of, this is the direction of electric field, you can see that these are representing the electrons. Electrons are moving exactly opposite to the direction of the electric field. Okay. Now I am taking, so here I am taking this cross section. See, this is the cross section I took. I can see some two electrons here, okay, in that cross section. Okay, now when I apply electric field, what is the velocity gained by the electrons? The velocity gained by the electrons is drift velocity, which is given by Vd. The velocity gained by the electrons is drift velocity is Vd. Okay, now consider a current carrying wire of cross section A. So this is the wire cross section is A. So at this point, okay, so I am taking this cross section. Okay, during a time delta t, suppose if I consider a time delta t, they are moving a distance d. So due to the application of the electric field, the electrons are moving exactly opposite to the direction of electric field, and the electrons are moving certain distance. Suppose for a time delta t, so for a time delta t, they moved a distance d. Okay, so if you know the velocity and time, okay, so the distance is equal to velocity into time. The velocity gained by the electrons is Vd, and the time taken for covering the distance d is delta t. So d is equal to Vd into delta t. Okay, now how many volume of electrons that passed a point is, so how many electrons will move is given by V is equal to A into D. So area, how many electrons in this area into D is given by V is equal to AD. How much volume of electrons is A into Vd into delta T. So how many charges will move is given by charge density into volume. Okay, how many charges are present in that material. So the charge density is given by, so the charge density is given by N. What is charge density? Is the number of electrons per unit area. Okay, the charge density is N. So the charge density is N into V. What is the volume? A into Vd into delta T. What is Vd into delta T? It is the distance moved by the electron in time delta T, and A is the cross sectional area, and so the number of free charges is given by N into A into Vd into delta T. So amount of free charge in the volume, so how many charges that are actually moving is given by delta Q is equal to E into N. So how many charges are moving in that volume into what is the charge? So the charges that are moving are electrons, so E into N. What is N? You got E into Na into Vd into delta T. So this is the number of charges in that particular volume. So what we till now calculated is how many charges are present, how many charges are present in that volume is given by delta Q is equal to E into what is N? N is the number of free charges into what is the charge, that is E into N. So N we got Na Vd into delta T, so E into Na into Vd into delta T. So what is current rate of flow of charge? So if I substitute I is equal to delta Q by delta T, so A is getting, delta T is getting cancelled. I got E into N into A into Vd. Okay, now what is current density? Current density is amount of current flowing per unit area. So if I substitute in place of E Na Vd, so I got current density is equal to J is equal to N E V D. So what I got till now? I got current density is equal to J is equal to N E V D. Okay, so let me go back. What I took a current carrying wire of a cross section A, and I apply electric field. Due to the application of electric field, the electrons are moving exact opposite to the direction of electric field. I considered that in a time delta t, the electrons have covered distance delta t. Okay, so the distance d is equal to Vd into delta t. I found what are the volume of electrons that are moving. How much volume of electrons that is moving, V is equal to A into Vd into delta t. How many charges I found, that is charge density into volume, and then I found how much amount of free charge in the volume V, and I found what is the current value, and I found what is the current density. I got current density is equal to NeVd. Okay, now what is the force experienced by electron upon application of electric field is, so when you apply some electric field, there will be force acting on the electron. That force is given by F is equal to minus E. This is what we have learnt in the electrostatics. And see, this is the force you are applying on the electron, and there will be some resistive force on the electron, that is given by minus mvd by tau. So the electron will try to resist the force, so that force is given by m, that is given by the minus m into Vd by tau. But under steady state condition, there is no force acting on the electron. What is steady state? The net force acting on the electron is 0, so the total force is 0. So if I find the total force, it is minus E mvd by tau, which is equal to 0. From this we got drift velocity is equal to minus E into tau by m. Here E is the charge of the electron, capital E is the electric field is applied, tau is the relaxation time, m is the mass of the electron. Now what is J? J is equal to NeVd. Now if I substitute Vd is equal to minus E tau by m, I will get J is equal to Ne square tau by m into E. Okay, I got J is equal to Ne square tau by m into E. Here I have neglected the minus sign. You can neglect that, no problem. And we know that Ohm's law is V is equal to IR, but the another form of Ohm's law is J is equal to sigma E. That is the microscopic form of Ohm's law. Okay, so J is equal to sigma E. So if I compare these two equations, here E is common, I can say sigma is equal to Ne square tau by m. You can see that sigma is equal to Ne square tau by m, where n is representing the current density, charge carrier density. That means how many electrons, n is representing how many electrons are present in unit area, and D is representing the charge of the electron, and tau is representing the relaxation time, and m is representing the mass of the electron. Another formula for conductivity, J is equal to sigma E, and J is equal to NeVd. Okay, so this is the formula we got. J is equal to NeVd and J is equal to sigma E. But we can define drift velocity as Vd is equal to mu E. What is this Vd is equal to mu E? What is Vd? Drift velocity. Velocity gained by the electron. Here I am introducing a new term, which is mu here. What is mu is? Mu is the mobility of the electrons. What is mobility here is ability of the electron to freely move in the metal is called as the mobility. So whenever the drift velocity is proportional to electric field and the Vd is equal to the proportionality constant mu is called as the mobility. So if I substitute Vd is equal to mu E here, so this my equation will become Ne mu E. So if I compare these two equations, I will get sigma equal to Ne mu. Okay, from this I can write J sigma is equal to J by E. So if I substitute here, I will get sigma equal to Ne mu. So we can see that the electrical conductivity is equal to electron concentration. That means N is representing the number of valence electrons and D is representing the number of valence electrons as well as the charge carrier density, and D is representing the electrons present, and mu is representing the mobility of the electrons in your material. Okay. So let me go towards the derivation again. So what we are trying to do, we are trying to determine the electrical conductivity. For this I consider a current carrying wire of cross section A. I find what is the free charges present, that we got NAVD into delta T. N is representing the number of charge density of the electron concentration, which depends upon the number of valence electrons. And from this I found amount of free charges, and from that I found current value, and from the current I found current density, which is J is equal to I by A. And we have, by using the force experienced by the electron and an electric field is applied, we found what is the drift velocity. And by using the drift velocity formula, we found sigma is equal to Ne square tau by m, and also we found another formula for sigma is Ne mu. So this is the derivation of the electrical conductivity based on classical free electron theory.